Hi, this is Ravinder. I'm now going to get into how Betacom is leveraging security to enable 5G as a service. In this section, I will talk about how we have taken the industry best practices to enable secure private mobile network solutions. We have talked about 5G as a service from security standpoint. We talked about that there are inherent secure capabilities that are there in both 4G and 5G that's adopted in the cellular technologies. And private networks actually leverages both 4G and 5G from enabling that security setup. But that's not good enough, right? I mean, there are always ways to go ahead and actually go around those security specifications and security setups. And hence, we take pride in terms of how we deliver that 5G as a service solution to our end customers. So when we go ahead and actually deliver a 5G as a service solution to our end customers, security is there from the beginning till the ongoing operations. By that, what I mean is we actually work with our customers from the planning phase in terms of, and to their design to install and to the operate phase. But one of the key elements that I want to highlight in terms of how we deliver 5G as a service for enabling private mobile network is that we want to make sure that we go ahead and actually meet the security objective of that enterprise. By that, what I mean is we have setups that the entire private mobile network is set up on premise. Now, by that, what that enables is you actually have your application. Your devices which are leveraging that application can seamlessly on your premise go ahead and actually get to your applications which are there on your on-premise data center. Now, if you actually have it in a cloud or in a private cloud or in a hybrid cloud, it's within the enterprise control to go ahead and actually route that traffic. And each segment of communication that's there, from device to the radios to the core to the enterprise firewall, is over a secure channel. In addition, what we have done is we have enabled a secure gateway within the entire private mobile network to make sure that the communication is actually secured via authentication and actually is encrypted. And when it comes to the communication back to our SSOC, so our SSOC stands for Security and Services Operations Center. That's one of the key differentiators for us. Unlike I know a lot of organizations are now trying to clinically adopt that, but what we have done is from the beginning, we have taken our services, which actually does 24/7 operations, and our security. It's one team that actually works collaboratively across all the events and the from network operation standpoint and security operations, so that our policies or procedures to go ahead and actually manage the events as they're happening are given the same level of attention, and at the same time, the handover between the teams is actually seamless. So that's another thing that we're trying to do differently to ensure we actually give better response to our customers when a security event does actually happens.
In the depiction here, you have a firewall, and since this is a managed service, is that a firewall that's normally under your control, or is that a firewall that's under the customer's control? How does that sort of work? One of the things I'm trying to grasp the situation is where exactly your kind of final line of demarcation is, and I'm sure it can probably vary, but just sort of curious how that normally works out for you all.
Absolutely. So Remington, thank you for that question. And the firewall that actually represented with that red color, that is enterprise firewall, and that's the demarcation we actually have. So we hand over the device traffic over to the enterprise on that port, and the entire network that's there is on private IP. So again, we actually limit the access from the exposure standpoint, which is all using leveraging private IPs. More so as well, and one other point that I will address is that, and let me know if I'm getting too much into the weeds as well, but the devices itself, we actually don't expose their IPs as well on the back end as well. So we actually do quite a bit of, again, matting onto our different elements so that we limit the exposure of the device even back into the enterprise applications as well.
Just a kind of quick follow-up question. What sort of and you may answer this elsewhere, what sort of visibility do you grant to the actual customer in terms of what's happening in the radio network and back in through the core infrastructure that you're managing? Do they have full visibility with their own external tools, or how do you expose that to them?
So we actually take all the access and all the monitoring data that we actually have, and I do have a separate slide on that, but let me just address that real quickly here. Is that we take the monitoring data and we actually put it into our AIOps tool, which is actually all in cloud. And we enable the dashboard access into for our customers. So they actually have on 24/7 real pulse of their setup. Now, if somebody comes in and actually says they want to have, raw data access into that, we would want to go ahead and actually talk about that because, again, we want to make sure we go ahead and actually limit the exposure of the data outside of the secured setup that we have established.
One last quick question. So you mentioned NAT and IP addressing. So do you all have any limitations or concerns around running either dual stack or just pure IPv6 across this infrastructure? I'm presuming the answer is no, because most of this is really just kind of a physical layer, but I just wanted to ask.
The answer is no. We're open to both IPv4 and V6. So. Planning is the first phase where we actually are getting to know the customer, and this is when we are starting off. We engage with the customer on really understanding what their needs are. So one is the business aspect, to really understand what the use case is around. Why do they need the private mobile network? The other is around what are their compliance and security obligations that these guys actually have, and we'll try to ensure that those are actually taken into by our team as we go ahead and actually design that setup. And in our design phase, when we get into that setup, of course, we start off by the design principles is we do follow the zero trust design principle in terms of giving access, whether it's for the customer or for our teams itself. We make sure that we take a look at their security specifications, and those are adopted in terms of the design that we deliver to the end customer in terms of the access that they need. On top of that, when we are designing each communication channel that we establish within the network or to their setup, we ensure that actually the security of that communication is there. On top of that, I do want to bring to the point is that in this entire setup, application data is something we don't get visibility into. That stays always with the customer. That's not something we have access to. So when it comes to the device applications that actually is on there, it's customer who decides what they want to put on there and how that application data is managed or monitored is actually within the customer itself. Now, what we do ensure is that when we are designing, we ensure that the communication channels for the control traffic, for the user traffic, and for the monitoring traffic is actually happening on the separate planes. Now, this is one of the security best practices that we actually adopted, so that we would try our best to make sure that everything is secure. But let's say if there is a breach that actually happens, we limit the exposure of that, and that's what we actually have tried with this setup. Where if you take a look at the control and user plane, that entire traffic is within the customer premise, sitting in the customer, where a customer has complete control of that setup that's there in terms of physical access into that setup. And when it comes to the monitoring traffic, that's where we take the traffic, only the monitoring logs and monitoring SNMP data that actually is taken into our SSOC, where it does not come, where it's taken into a cloud. That's where we actually have our AIOps tools. So 3 different planes for us to go ahead and actually communicate for control signaling traffic, the user data traffic, and the monitoring traffic.
I have a quick question. Speaking of data, so this is Ben Mason speaking.
Hey, Ben.
Speaking of data, like location data and call detail record data, all that kind of, I guess, underlying telemetry data that comes from a traditional handset and usage of a handset. How much of that is stored? How much is that accessible to the customer? And how is it generally secured?
So Ben. If you take a look in this setup, and let me, for this, let's focus on the middle picture, the user plane picture. Mm-hmm. that will actually give you a view that, you see the S gateway, the P gateway, and there is, imagine that there is put all of that actually into a core. There are other elements that are there that have not listed out there. All of that data actually is sitting out there, in that setup now. And this setup, is actually within the customer premise. When it comes to, in terms of the control of that data, now, the amount of data that actually is collected in the private network is not to the same extent as it's actually done by the mobile operators, right? Because the use case is not from that standpoint. Because keep in mind, what we're providing data traffic. It's, and if, let's say, a voice communication actually has to happen, it actually goes over the IP, right? Not the traditional circuit switch voice. So the answer is, all of the data actually is within the customer control, sitting on their premise itself.
Okay, so I guess a use case that comes to my mind is I think of, and this may not be a use case you're addressing presently, but if you have like delivery trucks, or like basically a station that's moving across a geographic area, is that a use case that you guys are covering right now, or is that? Because that obviously location data is important in that scenario of, where is my truck at, from both maybe something that could be serviced on the data side, or from a traditional 4 or 5G type of network can provide.
Yeah. So Ben, let me just give you a view, and Brian mentioned about this in his presentation about airports. Mm-hmm. So if you take a look at airports, you actually have these tugs that that are out there, and and that is a use case that we actually are enabling. And one thing that's not mentioned in this picture is we actually have GPS, because these cellular technologies do require a GPS for it to go ahead and actually give that precision communication. So GPS is actually enabled on that setup to support that kind of communication. And yes, for that use case, we actually have, but it's again within that boundaries, right? So it's within the boundaries of that airport itself. But yes, that data will be enabled by leveraging a GPS, and will be and information will be stored within that core setup that we have, again within the customer premise. We're not going out of the customer premise setup.
Perfect. Thank you.
Oh, you're welcome, man.
I jump in for Ravinder again for a quick question. You're mentioning customer premise. I'm just curious if you might be able to provide any kind of numbers or sizing in the maximum area that you could cover in a particular deployment. I don't understand maybe quite the scale of what you could do, or how large of a geographic footprint you can cover with your solution.
We can cover up to cities as well. So, and if you take a look at the airports, some of these airports are really large. There is one airport that we're working on right now. Its area is about 39 square miles. So that does not limit us, again, based on the scope that we have. So let's say if we actually have to provide a solution for a city where we have to enable communication for, I don't know, for their workers to go ahead and actually make sure, the city workers that are out there, so that they actually have uninterrupted access for mission critical applications, we could actually enable that. So again, based on the boundaries, so this is cellular technologies that can scale up to as much as you want. But again, when we are operating within CBRS band, so only in US territories for right now using that band. But as Brian mentioned, that in other countries, they are enabling that over different bands. So again, when you have to think about the limitation of this, it's beyond it's to what are the coverage that you want. That area is not the limitation for us.
Sorry, it's Justin here. Just to follow on from the question about the data. So it sounds like it actually can stay on customer premises. I'm buying this as a service from Betacom. Uh-huh. Under the contracts that are in place, who owns the data, such as particularly things like the metadata for the locations of things? That data could be quite valuable.
So customer is the one who actually owns that data. Again, that's where we are talking about when it comes to anything which is application related data, that is the customer who owns it.
Right, but some of this is the monitoring data from the control plane, which is more metadata. Is that also considered to be customer data?
So point is customer has complete access over the setup. And if you take a look at what Betacom is actually offering, we are the extended arm of our customers. When it comes to the control and access of their data, they have complete visibility into that setup based on their requirements.
Okay, because it's sort of, I have another question sort of related to that, which is that because this is a managed service, I'm not quite clear on how far into this network you extend to the devices for both management, monitoring, and also whose responsibility is it? So is this an end-to-end solution? So you provide all of the base stations and I buy remote devices from you and then you manage all of that for me? Or do I buy the equipment and then hand over management of that to you?
So Justin, very good question. So what we are looking at is it's a turnkey solution. You come to us, we go ahead and actually procure the entire setup based on your needs. Now, again, if you take a look at, you also asked about the end user devices. The end user devices that are out there, all the corporations and enterprises actually have their IT department, right? Now, if there are those enterprises that actually have CBRS-enabled devices that are already there, would continue to leverage that. We don't have to revamp that entire setup. What we are saying is we give you that flexibility that, that we leverage what you already have, and we come in and actually plug in the gap that's there from the connectivity piece.
Okay, terrific. And just to be clear, I was more thinking about the devices that you would provide outside of but it's nice to know that I can actually bring my own device if I want. And then essentially it's a customer choice as to whether I decide to retain ownership and management of certain end devices or just hand the whole thing across to you as a service. So I can choose based on my needs.
Absolutely. It's based on the use case applications, right? So, I mean, we can go ahead, we have turnkey solutions, and if there is specific need, we can work around that as well. Yep. When it comes to the next stage from when we have designed the setup and we are going into the field and actually doing the install, we have invested quite heavily into zero-touch provisioning. And this is actually allows for us to limit the number of hands that device actually have to be touched by, when it actually is going to be deployed on the field. More so from, more people touch it, more vulnerable you are from the configurations, from the configuration issues that could be there, and limit that access from just physical access into that setup. In addition to that, when that setup is there on site, we go ahead and actually ensure that before it's deployed, security hardening is actually done. And all of this actually is done by the resources who actually have years and years of experience doing this. We have been in this industry for 30 plus years, so we have the know-hows of these cellular technologies and actually enterprise industries to make sure that we bring the best security solutions to when we are doing the actual deployment for the customer. Lastly, when the network is up and operational, we actually go in and we have very rigorous, not just a performance test of how well the network is performing, but also security test to actually ensure that what we had looked at and promised from the requirements that we got from the customer from the security, what we actually had designed, and when we are doing the install, that actually meets the customer end objective. So we make sure that actually is done at the install phase before it's actually handed over to our operations team for ongoing management. Operations is our entire Betacom 5GaaS service revolves around our operations setup, right? I mean, this is where we actually have enabled and invested quite heavily into our SSOC, which is our Security and Services Operations Center. We offer this on a 24/7 basis. The investments we actually have made are into our AI ML-based applications. And back to Edward's question where he talked about detecting an anomalous behavior. This is where we actually look at how end user, a network device, network element should behave, take a look at the trending of that, and detect an anomaly when it actually does not behave based on what we have seen in the past. And it takes a use of all the log data, the alarms data, the event data, to come up with those anomalies. Now, when an anomaly does actually happen, it actually does the correlation, not just within that, let's say within the radio domain or within the core domain or within the security. It goes across the domain. So we have enabled that correlation across domains so that SSOC engineer who's out there gets a view of the, gets a view of the anomaly across the anomalous behavior across all the domains. And that's the way we are enabled through our AIOps system, and we continue to go ahead and actually improve upon that. I mean, again, more data we actually have, better off we are, in terms of detecting the anomalies and then reacting to them. And while we have made this investment to go ahead and actually do an ongoing proactive monitoring and management of our system, we also take actions to do preventive actions as well. And this is where we have taken into implementing our periodic vulnerability scans for both the enterprise network, but also our SSOC as well. And we present the dashboards of how the network looks on 24/7 to our end customers as well. And I'm really pleased to share that, that our SSOC is actually based in the US. So, with the technical resources available, in country to make sure that we actually don't have the time zone issues and things like that. So. Let me just dig a little bit more into our AIOps based security operations. If you take a look at this analogy, if you go from left to right, we starting from top. The solution components we actually have is we have radios, and we actually have antennas, and then we actually have the CUDU, which is distributed radios that we actually have out there. Then we see the core, then the networking, and then the firewall. Now these elements, as I mentioned, are security. Each node is security hardened. We implement CERT-based authentications. And wherever possible, and MFA where it's possible, and all the communication is through the security gateways. We take the data from here. Now, whether it's the log data, the event data, alarm data, we put that through our AIOps engine, which actually allows for us to go ahead and actually, take the data, crunch it, and actually helps us with noise reduction, so we don't see multiple alarms for the same event that's there. We actually do the alarm deduplication. We actually do the clustering and correlation of the events that enables our AIOps system to go ahead and actually do, a root cause. We're seeing root cause analysis. It actually is getting to that stage where it actually is getting more mature on that front, and it gives a recommendation action based on what it actually sees so far. Now that data is then handed over to our SSOC. So imagine the power that actually it enables our SSOC engineers, that they actually save the time when an event does happen to go ahead and actually not spend vital time, and could be minutes or hours in many cases, to go and actually go through the entire setup, and where they actually see where the potential issue could be, take a look at that issue, and then go resolve it. Now, of course, the setup is, we do leverage ISO 27K guidelines in terms of how we respond to the vulnerabilities. And last but not least, we have invested quite heavily into our AI, and our contact center is AI based as well. So we actually do have capability to do sentiment based analysis. So we have a customer engagement where the customer probably is not too pleased. It's not the customer has to go and actually ask for an escalation. The system will actually automatically does an escalation on the call itself.
Sorry, one quick question. So this tooling that you kind of lay out in some form here, how much of this is off the shelf? How much of this is homegrown? Is it? I'm sure it's a mixture of both, as with most SOCs. But is it 50-50, 75-25? Are there any vendors that you're able to share that you guys partner with?
So basically, we are working. So this ecosystem is actually a mix. Let me just start off with that. It's actually a mix of actually homegrown and some off-the-shelf shelf tooling. I can't take the name of the vendors. This is this is something that we're working to go ahead and actually further enhance that. But down the road, as we evolve the setup, we'll come out and actually share more data around that. But in terms of the mix, I would actually say that it's basically 70-20 right now. So 70 off the shelf and 20 is actually homegrown for us.
And can you define AI-based contact center a little bit better? Is it robots? Like, what is it?
So basically, a very good question, Karen. And this is where what we actually have is we actually have enabled these voice bots out there that actually does the context analysis. So like your voice is actually is put into a transcript, and then it looks for certain words, and then if based on those certain words, for example, hey, like this is a third ticket that I've opened, I'm not really pleased. As soon as I say like I'm not really pleased, I mean, really goes out to go ahead and actually then does an escalation for that call to the next level. So again,
that's the sentiment analysis part that you're referring to.
That's correct.
Okay, got it.
So to sum it up, when we take a look at our 5G as a service, we talked about the different security aspects around how we actually have leveraged the standard 3GPP security, configurations and parameters that are defined there into enabling a secure 5G as a service setup. We, entire setup is actually on customer premise. That's the first thing that we're trying to go ahead and get to, which simply means it's the control that we're giving to the end customer to go ahead and actually really own that while we are enabling that technology on the back end from the expertise standpoint for telecom and for security and on 24/7 operation standpoint. Now, this entire setup, as I mentioned, is based on zero trust principle. We actually leverage MFA, multi-factor authentication, and third-base authentication wherever the devices support that. We ensure that the user application is actually handed over to the enterprise itself. So we actually try to leverage the existing setup to the maximum. I actually work very closely with the customer to actually ensure that even that handover is actually secure. The traffic that actually moves between the user device, the radios, and the core, that's encrypted. And when there is a communication that actually does happen, there are separate channels for controlled signaling traffic, the user data traffic, and the monitoring traffic. When we are doing the deployment, we actually secure the network elements by hardening each nodes. SIM, which is a critical aspect because SIM is almost like a key, and I mean it does have a digital key on it. We actually are very particular about how we actually allocate those, and when we work with the end customer to actually do the end user validation. And let's say in cases where the device get lost, we actually have put in process and procedures around to make sure that communication comes back to us at the earliest, so we can take the right steps to deallocate that SIM, and follow that procedure around that. And from preventive standpoint, we take multiple measures, but periodic vulnerability assessment is one of the things that we actually follow across. And to top it off, we do this on 24/7 to make sure that we monitor the network and the management of the entire setup.
Can you maybe clarify? You mentioned this deployment and use case it's actually probably not on this side. This is more of a generalized question in relation to your service, right? So you mentioned a number of potential use cases, including airports and whatnot. Obviously, you have some amount of physical infrastructure that you have to put into the real world in order to support this service. Do you help customers deploy that physical infrastructure in terms of the whole, actually, running cabling, trenching, getting it where it needs to be, and/or for some of these use cases, I could see where you may have right-of-way issues or other kind of governmental concerns in terms of getting permitting to do things. I'm just trying to speculate here a little bit. And the reason I'm asking, just to be completely transparent, is that I help support a number of customers in medical fields, right? And I can see something like this being valuable from an EMS type service or something like that, where you could have your own private network infrastructure that you could leverage. It may not work for all use cases, but I could certainly see where that would be a potential use case. And getting that infrastructure in place would be difficult, I think. So.
Remington, you're absolutely right. I mean, that's where, if you take a look at the technology aspect, that's probably the easiest part here, getting and working through all the permits to make sure that we could organically deliver the solution, right away. I mean, even like putting antenna out there on a building premise, you actually have to make sure you have the right permits out there. Yes, and that's the USP for us, right? So Betacom has that 30 years of construction business. I mean, that's That's our other sides of the businesses. That's what we actually have been doing, right? We have been delivering, these solutions where we actually work with the cities, making sure that we actually, so we also have so much so that we actually have engineering staff on board as well. I'm talking about the construction engineering, not the technical, but the construction engineering on staff as well. And we actually partner with the local authorities to make sure that we actually have the right permits in place. And and let's say, like you're talking about, let's say the hospitals. I mean, and same thing is there with the cities as well. Same thing is there with the airports as well. I mean, you can imagine the amount of, the authorizations or the permits we need to technically enable that, especially when you actually have FAA involved, customs involved. I mean, there are so. Bottom line is we do go ahead and actually build that to the table as well. So we are the technology partner, but we also are the enabler. We actually have that construction experience under our belt to make sure that it's truly turnkey solution that we bring to the table.
And I would just add to that, it really has had the biggest influence on our ability to grow our business, is that we have such a rich, deep history in doing all the dirty work. The work nobody wants to talk about when it comes to deploying a technology solution. But to your point, there's a tremendous amount of work that goes on. For example, at one of the airports we pulled over 12 miles of cable and conduit. That's the reality of putting out there a turnkey network. And oddly enough, one of our customers was more interested that we'd actually done that kind of stuff than our ability to monitor it. And what really won us over with them, that we have this really rich history that's all done in-house. We're not outsourcing any of it. So we know that we can control the timetables, the timeline, the resources. We've been doing, as Ravinder mentioned, we've been doing permitting and design and install for 30 years. Probably many of the venues you've been to, or many of the networks you're using across the country, were good chance they were built by us. We're just taking that now and extending that into the enterprise. So you're spot on. It really is our true hidden value, is our ability to, if we have to get dirty, go pull cable and put in conduit.
I was just going to ask, since you guys have 30 years experience, how long does it take to go from 0 to 100? Zero, that I don't have any existing infrastructure. I have a large warehouse or a large campus, and I'm looking at 5G as connecting all my devices to a completely installed, completed project. How long does that rollout take?
So the question kind of gets broken down into two components. Is it an outdoor network or an indoor network? Historically, an outdoor network can take a little bit more just because of the permitting process involved. It's very different than indoors. But we were working with the municipality to build an outdoor solution to support dedicated broadband access for low-income neighborhoods. And we put together a timeline that we could stand that entire 20-mile radius up in 90 days. Now, again, it's much easier when you're working with municipalities because most of our tower locations are going to be on buildings already owned by them. So the permitting process was significantly less. But outdoor networks can take a little bit longer. If you're talking about an indoor installation, depending upon the number of access points or the complexity of the building itself, warehouses are very simple. We can turn those things around in a matter of a couple of weeks. A more complicated building with lots of walls, hospitals are very complicated. They can take us a few months, but we typically can stand these things up very, very fast. Our only limitation today is the same limitation as everyone, is supply chain. And of course, there's a global supply chain challenge. So I think what gives us strength in being vendor agnostic is that we have the ability to reach across a very broad subset of RAN vendors if we need to. They all interact very, very well across the industry. We continue to expand our portfolio on who those vendors are. So we find that because we're software, hardware agnostic, we've got the team in-house already in place. We typically can deploy extremely fast and have somebody up and running in a very short period of time.
That's quicker than I expected. So good job, guys. I think that's awesome.
I just want to cover something. So between the endpoint and the access point, you're using an X509 certificate already on the SIM card as part of your authentication, plus the device serial number that's registered somewhere, right? Then from the access point further into your network, you're basically using IPsec.
So on the SIM itself, you actually have a key that actually is enabled on there. So that's what there's that key that's what we go ahead and actually use to go ahead and actually do the authentication of that user device. Now, between the different elements, let's say the access point to the core node itself, or to the from the access point to the E node B, that's where we're using the X509 certificate to enable the IPsec communication.
Okay, so using the X509 to share the keys for IPsec.
That's correct.
But you're using the pre-shared or pre-registered SIM card key to get on the network in the first place.
That is correct.
And you also need the GPS enabled.
That is correct.
Are you doing GPS analysis of that device is in the wrong spot?
So what we're doing is this coverage that's there. The coverage is actually enabled for that specific area itself. So if you
So for example, what I was asking for is in your SOC, are you doing some sort of hunting for various weird things? One of them is a device that's normally in a very static area and suddenly it's somewhere else. Or a mobile device like a cart that happens to be sitting inside the concourse where it should never be.
Yes, and basically the tools that we actually do have ability to go ahead and take a look at. So every time a device gets a connectivity, we actually have an actual lat-long location of that device itself. Now that's what we actually are using into our AIOps tool to do an assessment. Now, if what we have also done is, so one is that specific within that geographic area. Now, let's say we have also done where if we take a device to where it should not be from the zoning standpoint, we also make sure that that's flagged through our tools as well. Second aspect is we also have done where we have done zone-based access for the devices. So let's say if you take a look at I'll go back to the airports again. You actually have Terminal A and Terminal B, or let's say Terminal 1, Terminal 2. If you have a device that moves from Terminal 1 to Terminal 2, we have enabled view into that as well, where we have ability to control that Terminal A devices should only be connected in Terminal A and Terminal 2 devices should only connect to Terminal 2. Because there are some regulations because of the airlines that are there that some airports mandate that.
Thank you. That clarified what was happening along the path. Appreciate it.
Absolutely. Thank you. Good question, Edward.